Assalamu alaikum friends, welcome to this MATLAB tutorial. Today I am going to teach you how to design load frequency control model of the power system using genetic algorithms in MATLAB Simulink software. Friends, most of the times the basic or conventional model of any system or power system is designed in the Simulink. This conventional model mostly uses PID controller. Now suppose we want to use the genetic algorithm as a tool to optimize the parameters of PID controller in the model to improve its response. Then how we can do it? Before going to answer this question, I want to highlight here that this genetic algorithm can be used for any model related to any field. First, you must notice that whenever and wherever PI or PID controller is used in any model, then the parameters of that PI or PID controller can be optimized by using the genetic algorithm. Therefore, this tool is very useful and can be applied to thousands of the research topics for the completion of master and PhD research objectives. Let's start. The first requirement is that we must have the conventional model of any system. For your convenience, I am considering the simple load frequency control model of power system as shown here. On this topic, I have already made the video, namely how to design load frequency control of power system using transfer functions in MATLAB Simulink software. Therefore, if you can watch this video and apply the genetic algorithm in this model to optimize the parameters of PID controller, then this model can be used for your master degree research or one of the PhD research objectives. Now look at the model. It may be observed that in this model we are using the PID controller. Double click on this PID controller block. You can see the parameters of the PID controllers are 2, 1 and 1 for P, I and D respectively. Let's check the frequency response using the PID controller at these values. Run the simulation by clicking on this play button. Double click on this scope to see the frequency response. You can see its response is satisfactory, which is obtained after several attempts. However, if you notice the response, it still contains large undershoot and very long settling time. Therefore, its response can be further improved by optimizing the parameters of PID controller using the genetic algorithm in MATLAB Simulink. Friends, in order to compare the response of this model with the PID controller and with the genetic algorithm, first copy the whole model and paste it here. Now we need multiplexer block to combine the response of both PID based model as well as genetic algorithm based model. Therefore, go to Simulink library, take the multiplexer block from here and bring it in the model. Connect the first port of the block with the output of this scope. Similarly, connect the second port of the block with the output of this scope. Now copy this scope and paste it here. Connect this scope with the output of multiplexer block to get the combined response of both systems. Friends, in the previous video we have discussed that genetic algorithm needs a fitness function to optimize the parameters of PID controller. The fitness function in this model is considered as the error of the system as shown here. Most commonly, integral time multiplied absolute error is considered as the fitness function for the best results. Mathematically, this error is given as below. It can be noticed from this equation that this error consists of integral of the error of change in frequency multiplied with time. Furthermore, the integral of time is taken from 0 to the final value of time. Now suppose if we run this simulation for 10 seconds, then it means that the time will be from 0 to 10 seconds. Let's design this integral time multiplied absolute error in the Simulink model. To get the absolute error, take this absolute block from here and bring it in the model. Connect this absolute block with this error signal to make it absolute error. Look at the equation again. Now we have to multiply it with time. Therefore, take this clock block from here and bring it in the model. Similarly, take this product block and bring it in the model. Now connect both clock block and absolute error with this product block in order to get their product. Look at the equation again. Now we need to integrate this block. For this purpose, take this integrator block from here and bring it in the model. Connect this block here. It may be noted that this integrator block will integrate the absolute error from time equal to 0 up to the total simulation time. In our case, the simulation time is set to 10 seconds. Therefore, it will integrate from 0 to 10. To see this error, take this display from here and bring it in the model. Connect this display here to see the error. Friends, we will shift this error to the workspace in order to use it for genetic algorithm. Therefore, take this to workspace block from here and bring it in the model. Connect it here. Double click on it and write its name as ITAE, which stands for integral time multiplied absolute error. Friends, as we want to optimize the parameters of PID controller, therefore we have to change the fixed values into variables. For this purpose, double click on this PID controller block. Suppose we want to give variable name as k, as there are 3 parameters of PID controller. Therefore, write here k1, k2 and k3 as shown here in order to make them variable. It may be noted that genetic algorithm is basically an optimization technique. Therefore, it mostly depends upon the type of solver used in it. Different solver may take different times. Some may even take hours to complete. To see the different types of solver, click on this simulation button. Then click on model configuration parameters. You can see this solver shows many options. You may choose any solver or keep the setting as it is. However, I choose ODE23S solver to get the results within short period of time. Another important point to change here is the value of relative tolerance. For best result, put here this value for relative tolerance. Otherwise, it may not provide the best optimization results. Friends, at this stage, we have done necessary changes in the model. Now let's start to discuss the basic program for fitness function in order to use it for optimization. For this purpose, see the MATLAB screen. It shows the basic fitness function program to run. Friends, this MATLAB fitness function program is very basic and will remain same for all types of power system models. Therefore, you can use this fitness function program as it is for your model too. I will share this model and MATLAB function program in the form of link in the description section of this video. You may download it from there. Now let's understand this MATLAB fitness function program. The first line consists of initialization of MATLAB function having the name cost. It may be noted that the name of this function and the name of the MATLAB program must be same. Otherwise, it will give error. You can see both these MATLAB functions as well as program has the name as tuning. In the MATLAB program, tuning is written with k in the parenthesis. This k is similar to the k variable which we have already defined in the model. It is because we are optimizing the value of k. The second line consists of another built-in function, namely assign in. which is used to assign any value from the model or workspace to the program. Therefore, this line shows that this function takes the value of k from the model or from the workspace and assign it to the variable k as shown here. The third line again shows another built-in function which is used to simulate the model in order to get the values of k, which are basically the parameters of PID controller. Friends, it may be noted that the correct name of the model must be written here, otherwise it may give error. The last line shows the output, which is the integral time multiplied absolute error. It may be noted that here length is written, as we know that the simulation time consists of 10 seconds. Now up to these 10 seconds there will be many values of error, but we want the last value at which time the simulation is completed. Therefore, this length is written to obtain the last value at the end of the simulation. Friends, at this stage we have done all the necessary changes in the model as well as in the program. Now we need to perform the optimization of PID controller parameter using the genetic algorithm. For your convenience, MATLAB has the optimization toolbox, in which various optimization tools are available, including the genetic algorithm. The command to open the optimization toolbox is optimtool as shown here. Therefore, write this code optimtool in the command window and press enter. You can see optimization toolbox window is opened. The first parameter consists of solver option. Click on this solver option. It will show many options to solve the problem. As we want the genetic algorithms, therefore click on this genetic algorithm option. Now it asks for fitness function. As we have already written the fitness function MATLAB program having the name tuning, therefore here we just need to call that function. This can be called by writing at the rate and its name tuning as shown here. Now it asks for number of variables. As we know that PID controller consists of three parameters known as P, I and D. Therefore write here 3. Now it asks to define the constraints. Friends, in this section only bounds are important. It asks for lower and upper values of variables. In other words, it basically asks the minimum and maximum values of the parameters of PID controller. You may choose any values of your choice ranging from 0 to 10, 50, 100, 1000 or even more. Suppose I am giving the lower bound to 0 and upper bound to 1000. It means that the genetic algorithm will search for the best results by changing the parameters of PID controller from 0 to 1000. Therefore, write here 0 3 times in the square brackets in order to define the lower bounds for all three parameters. Similarly, write here 1000 3 times in the square brackets to define upper bounds for the three parameters. Friends, as we know that genetic algorithm consists of 5 main steps. Among them, the first step is initial population. Therefore, look at this section. You can see it asks for the population to define. In the population type, it gives various options. Choose any option of your choice. For better results, keep the population type as double vector. Now it asks for population size. You may put any value of your choice. However, I am choosing the default number of population size, which is 50. Now it asks for creation function. Again, here it gives various options. You may choose any option of your choice. For this model, I choose uniform option. Keep the setting of initial population, initial score and initial range as it is. The second step of the genetic algorithm is fitness function. Therefore, it asks here about fitness function evaluation. In the scaling function, it gives again various options. Choose any option of your choice. For this model, I have chosen the scaling function as rank. The third step in the genetic algorithm is selection process. In the selection process, it again gives various options. Among these options, all are good. However, tournament selection always has the best results. Therefore, I am going to choose the tournament option here. Keep the tournament size and reproduction option as it is, or you may change it if you want. Another step of genetic algorithm is the mutation. In this option, it again gives various options. You may choose any option. I am choosing the adaptive feasible option for this model. The last step of genetic algorithm is the crossover. In the crossover section, again it gives many options. I choose arithmetic option for this model in order to get the better results. Keep the settings of other remaining sections as it is for best results, or you may change it if you want. Friends, as already discussed, genetic algorithm needs stopping criterions to end the program. Here 100 multiply with the number of variables generations are set as default stopping criteria. In my opinion, it is sufficient. However, you may increase or decrease it depending upon your choice. I choose here default values. In the plot function section, select the best fitness option to see its graph. In the display to command window, select the iterative option in order to see the error at every iteration. Friends, at this stage we have successfully performed the settings of genetic algorithm to optimize the parameters of PID controller for this model. To start the optimization process using genetic algorithm, click on this start button. Wait for a few seconds. Come to the model. You can see it has started the optimization of PID controller parameters. Furthermore, it may be noted that this model screen is continuously blinking, which means that genetic algorithm is continuously running the simulation to optimize the parameters of PID controller. It also gives the minimum error at the end of the every iteration for our reference. Friends, it may be noted that genetic algorithm is very slow processing algorithm. Therefore, it takes a lot of time to complete its optimization. Sometimes it may take even hours to complete. Therefore, you have to show patience and wait for a long time to completely see the final results. Furthermore, depending upon the processor and MATLAB version, it may take even more time to complete the optimization. Friends, you can see on the screen that optimization has terminated. The minimum error obtained using the genetic algorithm is shown on the MATLAB screen. Friends, in your case, this error may be different due to the different processor and MATLAB version. Furthermore, every time you start the optimization, it may give different results due to the random initialization of the variables. Furthermore, the optimized parameters of the PID controllers are shown in the form of variable k as shown here in the workspace section. Double click on this variable k to see its values. You can see it provides three separate values for proportional gain, integral gain, and derivative gain respectively. Now come to model. Double click on this PID controller block. Replace these K1, K2 and K3 with their optimized values in order to get the best results. Now run the simulation by clicking on this play button. Double click on this scope to see the combined frequency response. You can see the genetic algorithm has successfully optimized the PID controller parameters and has provided the best response compared to conventional PID controller. The genetic algorithm has best response in terms of extremely minimum undershoot and extremely lesser settling time as compared to the conventional PID controller. Friends, in this video I have discussed how genetic algorithm can be used to optimize the PID controller parameters of load frequency control model in the MATLAB Simulink software. This model can be used to complete your master degree or PhD research objectives. Furthermore, you can even write research paper from this model and you can publish it in any journal. By repeating the same strategy, the genetic algorithm can be implemented for any model related to any field in order to complete your master or PhD research objectives. For your convenience, I have uploaded this model and MATLAB fitness function program in the form of link in the description section of this video. You may download it from there. That's all for today's tutorial. If you like it, then don't forget to like my video, subscribe my channel and share this with all your friends so that they may also get benefit from this video. Thank you very much.